All right, guys, so we need to get started on this really quick because I think I'm going to get interrupted here in a minute. Today, what we're going to be doing is linear inequalities. So, is it a little blurry? Let's kind of autofocus this here. I don't know if that's any better. Okay, but a linear inequality is similar to a linear equation, which we've solved these already. But today, what we're going to be doing is graphing them. And however, an inequality symbol, however, a linear inequality uses an inequality symbol. And our inequality symbols, let's go ahead and write them. We have this is greater than. This one is less than. And remember, if it has the underline under it, it's greater than or equal to, and this would be less than or equal to. So this first example, let's see what it's asking us to do. So it says, given this inequality, determine which points satisfy the inequality. So basically, which point make the inequality true. So in order to find out what makes the inequality true, each point we're given an x and a y. So we have to plug those values in and see if the inequality statement reads true. So wherever I see a y, I'm going to put my 4. So 4 is greater than or equal to -2, and then I see an x, so times my x value, and then plus 9. Okay, so now we have to solve this out all the way. So bring down our 4 is greater than or equal to -2 times 7 is -14 plus 9, and -14 plus 9 is -5. So our statement reads 4 is greater than or equal to -5. So now we have to read that. We have to see if that makes sense. Is 4 greater than or equal to -5? Well, yes, it is. That is true. So these points satisfy this inequality. All right. Now let's try these points here. Wherever we see an x, or we'll put a -1. Wherever we see a y, we'll put a 3. So this is going to be 3 is greater than or equal to -2 times -1 plus 9. So 3 is greater than or equal to -2 times -1 is a +2 plus 9. Well, 2 plus 9 is 11, so 3 is greater than or equal to 11. Is that true? Nope. 3 is not greater than or equal to 11, so this does not satisfy that inequality. Now looking at the last one here, we're going to put -5 where we see y. -5 is greater than or equal to -2 times 10 plus 9. So now we will solve it. So this would be -5 is greater than or equal to -2 times 10 is -20 plus 9. -20 plus 9 is -11, so -5 is greater than or equal to -11. Well, is this one true? Now this one is a little bit tricky. So remember, when we're talking about negative numbers, the smaller the number, the greater the value. So -5 does have a greater value than -11. So this is true, and these points also satisfy this inequality. All right, now we're going to move into your favorite types of problems. These are real-world examples, all right, and inequalities. So these are basically word problems. So let's see. John sells t-shirts. Awesome. Plain shirts cost $5, and graphic shirts cost $7. Write an inequality. Oh, sorry. In order to match his product cost, he must make at least $1,200. So if it cost him $5 to make a plain shirt, I'm going to put 5p. All right. And then it cost him $7 to make a graphic shirt, so I'll put 7g. And I know that has to be greater than 1,200, or he won't be able to pay for his products. So this has to be greater than or equal to 1,200. All right, so that's how we would write an inequality to match that situation. So if he sells, so now let's look at B. If he sells 150 plain shirts, so this goes in for P, and he sells 60 graphic shirts, will he be able to cover the product cost? So we're going to plug these numbers in for their given variables. and see if we get more than $1,200. So 5 times 150 plus 7 times 60. Is that greater than or equal to 1,200? Let's see. So 5 times 150 is 750. 750 plus 7 times 60 is 420. It should be greater than or equal to 1,200. When you add 750 and 420, you only get 1,170, which is not greater than or equal to 1,200. So the answer is no, he will not be able to cover his costs. All right, so this right here, this is the answer. Okay, now moving on to letter C. If he sells 90 graphic shirts, so we're going to plug 90 in for G, what's the minimum number of plain shirts he must sell to break even? All right, so what we're going to do, we're going to use our inequality from a letter A. This is going to be 5P plus 7. Now where we see G, we're going to plug in a 90, and that's greater than or equal to 1,200. At this point, we're using algebra and we're trying to get P by itself. So we do 5P, bring down the 5P, and we're doing 7 times 90, which is 630, is greater than or equal to 1,200. We want to subtract 630 from each side. Remember, our goal is to get that P by itself. I'm going to move my work up here. So I'm going to have 5P is greater than or equal to 1,200 minus 630 is 570 or 570. We'll divide that by 5, divide that by 5, and he has to sell at least 114 plain shirts. Okay, so the first part is really just kind of making sense of these inequalities in the real world, in situations that could actually happen. You know, there are tons of people who make t-shirts, all right, and sell them. And the only reason you would do that is to make a profit, right? So now we are going to move into graphing linear inequalities. Graphing linear inequalities is a visual way of showing the ordered pairs that satisfy the inequality. So the first step, you have to make sure it's in slope-intercept form. Remember, it's y equals mx plus b. If you don't have that y by itself, you cannot graph the line. You have to do that first. And then you're going to use a dashed line. Okay, that's super important for less than or greater than. And you're going to use a solid line, and that's just the line that you're graphing with for this less than or equal to or greater than or equal to. So instead of having to read through those words each time, let's go ahead and make us a key. So less than or greater than equals dashed, and less than or equal to and greater than or equal to equals solid. So on these, the first thing that I want you to do is I want you to look at your inequality that's given. Does it have y by itself? If it does, I want you to look at the actual inequality itself. Okay, that's a less than inequality. That means we're going to shade below the line. So up here, I'm going to write below. And because it does not have the or equal to, I'm also going to write that I have to make a dashed line. All right, now I'm going to go ahead and graph because this is already in y equals. So let's pull out our slope. Our slope is 2 over 3, and our b, our y-intercept, is -1. All right, so let's graph it. Go down to -1, and then you're going to use your slope 2 over 3. So we're going to go up +2 and to the right 1, 2, 3. We'll go up +2 and to the right 1, 2, 3. Okay, I can't go up and to the right anymore, so I'm going to go back to my intercept and go down 2 and to the left. Just do the opposite. Down 2 and to the left. And now when I can't do that anymore, we're going to go ahead and connect these dots. But remember, because this is just less than, my line that I draw to connect these dots has to be a dotted line. It cannot be a solid line. I need to see that your line is dotted. That's a big part of this concept. Okay, and then anytime you have an inequality, just graphing the line isn't enough. You have to shade, because this says y is everything that's less than this equation. Well, everything that's less than this equation would be below it. So below the line towards smaller numbers is everything below it. Okay, now looking at the next one, y is already by itself, so I'm looking at this inequality. This is a greater than sign, so I'm going to shade above. And it's greater than or equal to, so I know I can go ahead and make a solid line here. So now let's pull out our m, which is -4. Remember, your slope is usually rise over run, so we can go ahead and put it over 1. And then our b, which is our y-intercept, is 0. All right, so we're going to start with our 0. That's our y-intercept. And we're going to graph this line by going down 4. -4 is 1, 2, 3, 4. To the right 1. And let's go down 4 one more time and to the right 1. We can't go down and to the right anymore. We're going to go back to the intercept, and we're going to go up 1, 2, 3, 4, and to the left 1, up 4, and to the left 1. And this time when we connect our dots, because of the equal to, that it goes with the inequality, we can go ahead and draw a nice solid line. All right, and because this is greater than, we're going to shade above the line, so towards greater numbers, and that is this way. All right, now let's go ahead and flip over to the back. Okay, now on the back here, this is where you have to start to do you're going to have to start to do some math. You can't just start to graph it. You have to get it in slope-intercept form, and that is y equals mx plus b. And as you're doing that, don't forget to flip if you multiply or divide by a negative. All right, so let's go ahead and take number 3 here. Let's solve it for y first. So minus 5x, we move the x by changing the sign. So we left with 3y is less than or equal to -5x plus 12. All right, then we want to divide by the number in front of y. So we'll divide by 3, divide by 3, divide by 3, and we get y is less than or equal to -5 over 3x plus 4. So now that y is by itself, go ahead and look at that inequality. Tell me how you're going to shade. Tell me how you're going to draw your line. This is a less than, so we'll shade below. And because it's less than or equal to, that's going to be a solid line. Go ahead and tell me that. And really, I'm having you tell me that, so you're telling yourself that. So then we can pull out the slope, which is the m is -5 over 3, and the b is +4. So we're going to go up to 4. 1, 2, 3, 4. Then we're going to use the slope -5 over 3. So we're going to go down 5 to the right 3. We'll go down 5 more and to the right 3. And that's as far as I can do that. So go ahead and connect these dots and draw this line. All right, now we're shading below the line, so that would be under it. And under that line would be right over here. Okay? All right, this is the last example that we have time for today. I will finish up these notes tomorrow probably. So let's go ahead and solve this one. We have to solve it for y first. So we're going to move the x by changing the sign, minus x, and bring down, make sure you bring down that negative in front of that 6. So -6y is less than -x minus 12. And then we want to divide by -6. Divide by -6, divide by -6. Remember, when you divide, you have to flip the inequality symbol. So we have y now is greater than -1 over -6 is just 1 over 6. Move the x out to the side. Negative 12 divided by negative 6 is going to be plus 2. All right, so once you have the y by itself, tell me, is it going to be, are we going to shade above or below? Well, that is a greater than, so we're going to shade above. And then that does not have an equal sign, so this will be a dashed line. All right, now let's go ahead and plot this thing. Pull out our slope. M equals 1 over 6, and B equals 2. So we're going to go up to 2, put a dot for our y-intercept, and then we're going to use our slope. Up 1, to the right 6. 1, 2, 3, 4, 5, 6. We can't do that anymore, so we'll go back to our intercept and go down 1 and to the left 6. 1, 2, 3, 4, 5, 6. And we can connect our dots. But remember, this has to be a dashed line. So when you connect your dots, make sure you're doing dashes and you don't accidentally draw a solid line. Sometimes I call these dotted lines, so don't be confused by that. And we decided to shade below, so we're going to shade below here. All right, very good. Okay, so now you're going to have a worksheet to work on. Remember, tomorrow is Friday, so we will be doing a note check. It'll be the last grade of the 6 weeks, so make sure that you have all your notes completed before tomorrow and get to work on your worksheet.